Okay, Algebra 2, I'm back. We're working on section 6.4, which is factoring polynomials and working with that. And I'm looking at different factoring patterns. Remembering you should always look for a GCF, look to factoring a basic trinomial, difference of squares. But then I introduced a couple of new things to you, which were cubes. And being able to look for those and identify those and factor those. And also perfect square trinomials. Let's do two problems with you here that will encompass a couple of these different ideas. So the first problem, I'd like you to look at 4a to the fourth negative 108a. And you're going to be asked to factor. Okay, I'm going to factor that. So again, you look at a polynomial, the first thing you always should look for is, can I take out a GCF? If you can, you're taking a factor away or factors, and that's going to reduce the complexity of the polynomial. So if I look at this, here I see I've got 4 a's, I got an a. I know I can take an a out. Then I look at my numbers. 2 goes in, but in fact 4 goes in. Now if you take out a factor and it's not the GCF, it's almost counterproductive. It's kind of like fixing half a cavity. No, you need to fix the whole thing or you got a problem. So I want to take out 4a to start this problem. And if you do that, 9 chances out of 10, you're on your way to success. 4a comes out of that, I'd have a cubed. This will be negative 27. And now I would sing, do you see what I see? It's cubes. It's difference of perfect cubes. So now I keep factoring. So 4a comes down. I recognize I got cubes, which if you recall, you want the cubic root and then the square left over. So the cubic root of a cubed is a. Cubic root of negative 27 is negative 3. Let these dictate the rest of this. To get the head, you square. So a squared. To get the tail, you square. Negative 3 squared is positive 9. To get the middle, you have to have a memory. And your memory says multiply these, but change the sign. Positive 3a. All right? And you'd have it. Okay. All right, second problem. Let's look at this one. I'm going to go with the 4 again. 4a cubed, negative 32a squared, and positive 256a. All right, looks like a beast. Let's break this thing down. How about a GCF? Anybody see it? All right, I'm seeing 4a again. Take that out, see what's left. Let's see, 4a be a squared, negative 8a, and then 256 divided by 4 is 64, so this is 64. Okay? Now I look for this, and I decide, is there anything more I can do to it? It looks like it might be a PST, but you got to be careful. This 64 would be half of this squared. Is it half of this squared? No, it's not. So this one at this point in time would be done. Okay? Now, real quickly, I want to just change one thing. If I'd have had 4, put this down. If I put it down, I'm putting it down. If you had 4a and you had a squared minus 8a plus 16. Now that's going to change the story because now this would in fact be half of this squared, and now you have a perfect square trinomial. So now we would want to continue. If you remember, we were going from standard form into vertex form when we were doing quadratics. So it would be square root a, square root of 16 is 4 or negative 4. In this case it has to be negative 4, and I would have that factored. Okay? So guys, when you get these quartic and cubic and square, any of these polynomials, look to take a GCF out and then look to continue factoring and ask yourself, what do I have? Is it a PST? Is it cubes? Look for these patterns. Factoring successfully is very important if you're going to break down polynomials and work with them. All right, that's it.